In this video, I want to show you how you can solve a polynomial inequality using a graphing calculator. And there are two ways that we're going to do this. We want to use a graph of p of x, which is equal to x minus 2 quantity squared times x plus 5 to solve p of x is less than 0. So in the graphing calculator, you're going to press your y equals screen and input the polynomial function. To get the x variable, you're going to use the xt theta n key. And to get the exponent, you can hit the x squared key or use the caret symbol to do that. And now what you want to do is graph. When we graph in the standard window, notice that we see our zeros of -5 and 2. We see that it crosses the x-axis at -5. It bounces off at 2, which is based on our multiplicity of the zeros, so that's good. If you want to see like the true picture, then you can look at the table to figure out how you can resize the window. If I look at the table by going to second graph, I really need to think about what's happening between the -5 and 2 so that I can resize this window, because our end behavior is up to the right and down to the left, so I don't really need to worry about that. But between -5 and 2, notice that it's going up to 50. So I can change my window. And instead of the standard window of -10 to 10, I'm going to change my min and max for the y to -60 to 60, and then graph. So now I see a complete picture, still with those same zeros, -5 and 2. But what am I really doing? The reason I'm looking at this graph is to figure out what region, or what interval of x is a graph below the x-axis, because I want to find out where is y less than 0, and that is below the axis. Well, it is below the axis only to the left of -5, and it may be helpful if you draw a vertical line through those zeros, down through -5, and down through 2. So it is only below to the left of -5, which is from -infinity to -5. And since we want strictly less than, I cannot include the 0 of -5, so I use a parentheses in my interval notation for the solution set. A second method that you can use is actually to input the entire inequality in the calculator. So I'm going to go to y equals, and this time I'm going to type in the polynomial x minus 2 quantity squared times x plus 5, but now I'm going to input the inequality symbol less than. And to get the inequality symbol of less than, I'm going to have to use my test menu, which is on the calculator by doing second and math. So if I press second and math, that's going to bring up some inequality symbols, and you're just going to select the one that is less than, which is option 5, 0. And now we're going to press graph. And I'm in the standard viewing window. And this may look kind of odd, but what's happening is the graph is highlighting really what x values or what interval satisfies that inequality. And it's using what's called Boolean algebra by assigning a value that makes it true, 1, and a value that makes it false, 0. And so everywhere we see a 1, that is where the y value is 1, are the x values that satisfy that inequality. And so this is, again, if I count this, -5 is where my interval changes, right? To the right it's 0, but to the left is 1. And so the only region that satisfies this is from -infinity to -5. Again, I have to know what happens at -5, but because it's less than, I have a parentheses. I can also look at the table by doing second graph, just to make sure you understand what's happening. And so for every x value that satisfies this inequality, I'm assigning a value of 1, which means that it's true there. But everywhere else where it has a 0, these are input values that make that inequality statement false. So they would not be included in the solution set.